Hi everyone, I'm happy to share my Cargo Vessel Tracker project, which is a live dashboard tracking cargo vessel movements in San Francisco Bay, built on a real-time data pipeline that ingests AIS position broadcasts from container ships and other types of cargo vessels as they approach the port of Oakland. In this video, I'll walk through how I built it from raw WebSocket data to a production-style Databricks pipeline to this Streamlit dashboard. I built this project drawing on my background in freight forwarding and NVOCC logistics, where tracking vessel arrivals and port congestion directly influenced freight planning decisions. The data source is AIS, which means Automatic Identification System, a global standard that requires all commercial vessels that are over 300 gross tons to continuously broadcast their position, speed, heading, and identity. Every dot on this map is a real cargo vessel broadcasting its position in real time. The pipeline starts with a Python WebSocket collector that connects to the AIS Stream API and filters for vessels within a bounding box. For those of you who are not familiar with what a bounding box is, it is an imaginary rectangle that surrounds an object, and in our case, our object is the San Francisco Bay. The collector writes incoming position reports and vessel static data to JSON line files locally, rolling over to a new file every 15 minutes. A separate uploader script running in parallel picks up all completed files and pushes it to a Databricks Unity Catalog volume using the Databricks Software Development Kit. Inside Databricks, the pipeline follows a medallion architecture across 3 layers. Bronze ingests the raw JSON files using autoloader, landing them as is into a Delta table with full schema inference and checkpoint tracking. Silver parses the nested JSON data, extracts clean fields like latitude, longitude, speed, and ship type, and uses Delta Lake's merge into to maintain one row per vessel showing its latest state. A separate append-only table keeps the full position history for our route visualization. Gold filters down to cargo and tanker vessels using ship type codes 70 through 89, joining position and static data into a clean, query-ready table. The entire pipeline runs automatically on a schedule via a Databricks job with task dependencies ensuring bronze completes before silver runs and silver before gold. The Streamlit dashboard connects directly to the Databricks Gold table via the SQL Warehouse connector, querying fresh vessel positions on every refresh. The live map shows current cargo vessel positions color-coded by navigational statuses: orange for underway, purple for anchored, and green for moored. The sidebar shows fleet summary metrics and lets you filter by navigational status and ship type. Below the live map, the route history layer uses deck.gl's path layer to render the full movement track of every cargo vessel over the collection period. Here, you can see vessels transiting the main channel, circling at anchor while waiting for berth assignments at the port of Oakland, and tankers running north to the Richmond terminal. The full project is fully viewable on GitHub, including the collector script, the uploader script, and Streamlit app script. The tech stack covers Python, PySpark, Delta Lake, Databricks Autoloader, Databricks Jobs, and Streamlit, built end-to-end as a portfolio demonstration of a real-time data engineering applied to a domain I know from my freight forwarding background. Thanks for watching.